Today we're going to be expanding binomials using Pascal's triangle. What do I mean by that? Well, let's just look, huh? So I need to share my screen so you can see it too. There we go. Now, we're going to use Pascal's triangle to expand the binomial. So what does expand mean? Let's first do that. Well, expand, if I have x plus y cubed, that means that I have to write it 3 times. X plus y times x plus y times x plus y. That's what expanding means. You multiply it out. So if there was a 5 there, I'd have to have 5 of these guys all the way over to here, right? If that was a 7, 1, 2, 3, 4, 5, 6, 7, x plus y's, you know? So there has to be a better way. Well, I'm going to show you the long way, and then I'm going to show you the short way, okay? So the long way is where you have to multiply by FOIL. We know how to do that. We have to multiply these guys together, right? So x times x would be x squared. X times y would be x times y. Now here I have y times x, but I'm going to write it in alphabetical order because y times x is the same thing as saying x times y. So I'm going to write x, y, and then y times y is y squared. Now I line them up so I can see what's the same. I can't add anything to x squared, so that's just x squared. But these guys are exactly the same. 1 plus 1 would be 2xy plus another y squared. Now, we only did 2 things. We did these 2. I still have another one, so I have to do it again, right? Imagine if I had 2 more or 3 more or 4 more. I just have to keep multiplying and multiplying and multiplying. Yeah, so this is called expanding. So x times that would be x to the third. X times this, remember, you just multiply times the x. So you're adding, that's going to make that x squared y 1. So the 2 doesn't change, the y doesn't change. All right, and then x times the next one, x times y, well, that would just be y squared, just like that. See? Now then I have to take the bottom guy, or the back guy, the last one, y, times all 3 of these. So I start over here, y times plain old x squared, that would just be x squared y. How about y times 2xy? Well, that would be 2 doesn't change, x doesn't change, but the y becomes y squared. And then y times that would be y to the third. You with me? Now, I add these things together, the ones that are exactly the same. See, this is an x2 with a y1. Well, here's another x2 with a y1. I can add those together. That makes 3x2, y1. And here's an x1, y2. Well, there's another x1, y2. I can add those together. Woohoo! And now this, believe it or not, is the answer to this. Now imagine doing it again. What if it was x plus y to the fourth? I'd have to do it again. And then what if it was x plus y to the fifth? I'd have to multiply all of this out again. So we're saving us some little time, and in order to, if we do it using Pascal's triangle, we're going to save us some time. So what is Pascal's triangle? Let's look right here. Lo and behold, this is Pascal's triangle. Let's zoom in on it, huh? There we go. Now then, what does Pascal's triangle do for you? Well, see, these numbers, 1, 3, 3, 1, hey, look, they're the same as this. 1, 3, 3, 1. So if I knew what letters to put next door to these numbers, see, I already know what the numbers are. So what if I wanted to know, x plus y to the 4th power. Whoops, I zoomed in too much. What if there we go. What if I wanted to know x plus y to the 4th power? Well, instead of doing all of this stuff, right, I could use Pascal's triangle to find the answer if I just understood what letters do I have to put next to these numbers, right? Well, look up here. Let's zoom in again. Zoom, 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 okay? So if I want x plus y to the 4th, let's look and see what the letters have to do. See, the letters have to be, the x numbers have to be descending. Here's x4, there's x3, then x2, then x1, right? And then there's not any x's, right? So the x numbers are descending and the y values are ascending. There's not a y there, but then here's a y1. There's a y2, there's a y3, there's a y4. So see, if I wanted x plus y to the 4th power, this is where I get it. This is it, right? The letters, the x numbers go down and the y numbers go up, right? And then these values that we had down here, 1, 4, 6, 4, 1, hey, that's what this is. 1, 4, 6, 4, 1. Ha! All right. Well, let's see if we can do x plus y to the 5th. So what if I wanted, let's say, x plus y to the 5th? That's what I want, right? Well, look, the very first one, let's move this out of the way, maybe. The very first one says you start with x only, then the x number goes down, continues to go down, and the y number goes up. So let's go back here and say, okay, so I'm going to start with the x number, 1x to this power, power 5. Then what's the number? Well, the next number, see, I started with 1. Now the next number is 5. So I'm going to write 5x. Now remember, the x's go down and the y's go up. So this was y0. Now this one's y1. What's the next one? Well, according to my list, I have 10. So I would go 10x to the 3, right? Because the x's are going down, 5, 4, 3, and the y numbers are going up. So that's y1. This one has to be y2. Let's do another one. What's the next number? Oh, it's 10 again. 10. Now the x's are going down. What do you think it's going to be? All right, x2, y3. Number 5. That's the next number, number 5. And then if this was 5, 4, 3, 2, this x has to be 1, right? And you can put the 1 there if you want. I don't usually, but you can. And then y has to be to the 4 because the y's are going up. Here it's y1, there it's y2, there it's y3, there it's y4. And then the last one, of course, is 1. It starts with 1 and it ends with 1. And this would be y5. So the one at the beginning, x5, has no y's at all. That's y0. But then the next one has x4, y1, x3, y2. See, so we know what the numbers are, and now we know how to make the letters. Aha! So how do I make the numbers for the next row? What if I wanted x plus y to the 6 or x plus y to the 7? What would I do? Well, let me show you. See, Pascal's triangle, I can find Let's use a different color, maybe blue. Okay. I can find row 6. So if I wanted to do row 6, I know that it has to start with 1 because every row starts with 1. So I'm going to have a 1 right here. Now, how do I get these rows? Well, let's investigate. Look, 1 plus 3, that's 4. Right? 3 plus 3, that's 6. 3 plus 1, that's 4. Look what they did. All they did was add these, and that came 5. They added these two together, and that became 10. They added these together, that's 10. They added these, that's 5. So what's this next number down here? Well, 1 plus 5, that would be 6. So 6 is the number that goes right there. How about 5 plus 10? That would be 15. Yay! 10 plus 10? 20. 10 plus 5? 15. 5 plus 1? 6. And then there has to end in a 6. All right? So, easy smeezy. Look, I can do any row I want. The next row would start with 1. And then the next would be 7. Right? 1 plus 6. 7 plus, or 6 plus 15 is 21. Yay. 15 plus 20, hey, that's 35. 20 plus 15, another 35. 15 plus 6, another 21. And then 7, and then 1. So see, I can find any row that I want. And then since I know the letters go down, the X letters, this would be X7, and this would have to be X6, Y1. And this would have to be X5, Y2, right? And so the letters go down, the X letters go down, and the Y letters go up. So we can do that. That is the end of what is Pascal's triangle. Now I'm going to do another one and show you how to use it. Okay? Bye.